Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series of videos dealing with logarithms, is going to, I suppose, concentrate on how we solve logarithmic equations. Okay, so this is going to be solving logarithmic okay, equations. Okay, and let's say this is example one. So let's say example 1 in this particular section. Okay, so let's consider the following logarithmic equation. Let's say we have 2 log x to the base 2 minus log of, let's say, 3x minus 4 to the base 2, and let's say that's equal to, let's say for argument's sake that that's equal to 1. And what we'd like to do is we'd like to solve this particular equation, if that makes sense. Okay, so well, what should we do? We should try to apply the rules of logarithms. Okay, and they were the rules that we set out in our previous videos. For example, the addition rule, the quotient rule, the power rule, the change of base rule, and so on and so forth. Okay. So maybe what we'll do is we'll try to just get them all in the form, all these logs in the form of log of something to a particular base. Okay, so what we can actually see here is we have 2 times log of x to the base 2, and let's just keep in mind that our power rule, which says that the log of let's say b to the n to the base a is the same as n times the log of b to the base a. Okay, so that if you have a factor times a logarithm, okay, if you have a number times a logarithm, it's the same as raising I suppose raising this particular value to the actual power. So the log of b to the power of n to the base a is the same as n times the log of b to the a. Okay, so actually we can reverse this. We can go back in this direction. You can see this looks quite similar to this, where n is 2. We have the log, a, the base is 2, and the value that we want to get the log of, b, is our x. So actually this implies, I suppose, if this is equal to this, well then this implies that log of x squared to the base 2 minus the log of 3x minus 4 to the base 2 must be equal to 1. And also let's recall, I suppose, our quotient rule, the quotient rule, okay, that says that the log of a over b to the base, let's say to the base c, it's the same as the log of a to the base c minus the log of b to the base c. Okay, so actually this is a quotient. It's the right hand side of this quotient rule. So we can bring this back together. So this implies that log of x squared over 3x minus 4, okay, to the base 2 must be equal to 1. Okay. So, in logarithmic terms, what does this mean? It means that the log of this number, okay, to the base 2 is equal to 1, which means that 2 raised to the power of 1 must be equal to this number. Okay, the question is, what exponent should we raise 2 to? Okay, to get this particular number here, x squared over 3x minus 4. And actually, we've been told that this particular log is actually equal to 1. So what we know now is that this implies, maybe I'll move this across, this implies that 2, the base, to the power of 1 must be equal to x squared over 3x minus 4. This implies that 2 times 3x minus 4 must be equal to x squared. Okay? You see, we're actually going to end up with a quadratic here. Okay? Actually 2 to the 1 is just 2, okay? And then I cross multiplied, or I multiplied across by this factor here, 3x minus 4. What does this imply? This implies that 6x minus 8 is equal to x squared, which implies that x squared minus 6x plus 8 must be equal to 0. Okay, so we're going to factor this particular quadratic here. So what does this tell us? Well, then this tells us that x squared, let's say, well, what are the factors here? Well, the factors seem to be 2 and 4. Okay, no, maybe are the factors 2. The factors in this case here would be, okay, well, what do we multiply? 1 times 8 gives us 8. Okay, and the factors of this is 1 times 8 minus 1 times minus 8, 2 times 4 minus 2 times minus 4. Actually, that's it. Minus 2 times minus 4. Okay, minus 2 times minus 4 gives me 8. And minus 2 plus minus 4 gives us minus 6. So our actual factorization of this is is x minus 2 times x minus 4 must be equal to 0, which tells us that this implies that, well, this implies that x must be equal to 2, or x must be equal to 4. Okay, so that under these particular conditions we should have this particular equation given us 1. Okay, maybe we'll just sanity check this. Let's just verify. Okay, let's do that verification. Okay, so let's just write down our equation again, our logarithmic equation. We have 2 log of x to the base 2 minus log of, yes, it's 3x minus 4 to the base 2 must be equal to 1. And let's just say let x equal 2 and see what we get here. Okay, so when x is equal to 2, the left hand side, okay, becomes it's 2 times log of 2 to the 2 minus log of 3 times 2 is 6 minus 4 gives us 2, so that's 2 to the 2 is equal to 1. This is log of 2 squared, okay, to the base 2 minus log of 2 to the base 2 is equal to 1. Okay, oh, sorry, I'll just take the left hand side. Okay, so ignore that. That's equal to this, which is equal to, well, this is log of 4 to the base 2 minus log of 2 2 to the base 2, which is equal to quotient rule. This is log of 4 over 2 to the base 2, okay, which is equal to the log of 2 to the base 2. Okay, and the question is, what should we raise 2 to? What power should we raise the base to get this particular value 2, which is equal to 1? So we have the log of 2 to the base 2 is equal to 1, which is the right hand side. So we can actually see that this solution works. What about when we have x is equal to 4? Let's see what happens. So when let x is equal to 4, so we're actually evaluating the equation now under the conditions of equality. Okay, so when x is equal to 4, we have the left hand side becomes it's 2 log 4 to the base 2 minus, well, we have 3 times 4 is 12, minus 4 gives us 8, so it's minus log of 8 to the base 2. This becomes, well, this gives us log of 4 squared to the base 2 minus log of 8 to the base 2. 4 squared is 16, so this gives us log of 16 to the base 2 minus log of 8 to the base 2. Once again, this is a quotient. This gives us log of 16 over 8 all to the base 2, which gives us log of 2 to the base 2, which is equal to 1 as required, yeah, which is the right hand side. So we can actually see that the solutions that we found earlier on, okay, that these particular solutions here, actually are solutions to this particular logarithmic equation. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video, another video in a series of videos dealing with logarithms, I hope that it was in some way intuitive, and more importantly, I hope that was helpful for you. We'll have a look at another video in a moment of solving logarithmic equations, something a little bit more complicated. So once again, thanks for watching. Okay, bye bye.